Okay, so homework number 9, section 1.9. Number 2 is just notation, F inverse. Number 4, reflection across the y equals x line. That's not helpful, is it? Number 14. You guys should have written the directions, but I can already tell what type of question it was. Wasn't it a verifying question?
Yep.
Because you were plugging in stuff, hopefully. Now, what I said earlier, you might not have caught it. The book shows you have to do both. For sake of time, if it was, say, on the test, and I asked you to verify 2 functions or inverses, or find the inverse and then verify, you only have to check it once. Once is enough. Check it carefully. They should have both simplified to be x. Number 20 was just one of those flipping ones, right? You had to sketch it or something like that? And if you got stuck, I tried to help yesterday. If you got stuck, my hint would have been to flip that guy and get this guy. I would have said you should have sketched the line y equals x. And then if you sketch the line, hopefully you could flip it. Piece, that one flips. Phi, that one flips. Piece, that one flips. That one flips. See how maybe you could have gotten that guy? Maybe not perfectly, but at least approximately. Draw that y equals x and flip it piece by piece. Remember next one. Oh, here's one. 1 over x and 1 over x, it is its own inverse. When you plug it in, it's kind of weird. But 1 over x is the same thing as the reciprocal, or you can think dividing by 1 over x is multiplying by the reciprocal. It's one of those weird ones where it is its own inverse. And my question to you again, does the graph seem to show that it is its own reflection?
Yes. So
the graph kind of gives you a hint to those. Maybe that's a shortcut. The graph gives you a hint. 42, lame sauce. You guys just had to use your calculator. But pause. Could a few of you have looked at this and said it's a quadratic? Of course it fails. Yeah, maybe it would have saved you some time, huh? But you could use your calculator on this one. True, it does not pass the horizontal line test, so true, it does not have one inverse function as its inverse. Here's the other weird one, but you guys had to find it. It's another weird one, but once again, what do you guys notice if I draw the y equals x? What is it? Its own reflection. That was a hint. If you had switched the x's and y's, though, here we go. Switch the x and y's, solve by multiplying and dividing. It was its own inverse. C said something about the graph's the same. Oh, because you just graphed the other, the exact same equation. And then letter D. This did ask for domains and ranges, but since you have the graph, couldn't you just ask yourself the question, how left, how right, how low, how high? As easy as that. How left, negative infinity. How right, positive infinity, but what do you have to be careful of? What does it not cross? Which is y, and you say everything but 0. It's fine, negative infinity to positive infinity, but not 0. If you guys were being super cool and using interval notation, you would have had to use negative infinity to 0, parenthesis, 0 to infinity. You would have had to exclude 0. Does that make sense? So everything forever left to 0, but not 0. And then from 0, but not 0, to infinity. Same thing range. Negative infinity to 0, but not 0. 0 to infinity, then we're good. So you can put it that way or that way. 64, you guys just finding the inverse? Are you just switching x and y, solving for y? Okay. Switch x and y, solve for y. The place you might have gotten a little stuck is that whole plus and minus square root, which is a hint, as an indicator that p was not going to work. It takes 2 functions to make an inverse, and here's what I showed you. The book isn't going to put f inverse because there are 2 functions, so we can't just name it one inverse function. So they just call it y. This technically is an inverse relation, but they say that's not one function, so I have to say no. Okay, whatever. It is the inverse relation, but since there are 2 pieces to it, they say it's not a function. It's not one function, and they're right. It's 2, not 1. It's 2, not 1. Is that the last? Okay, that's the last even. Let's go check out those funny last ones though, because remember I said the last few, something about domain got funny. What were those last ones? Oh yeah, 73, I was right. Go team. Are these the ones that got messy, 69 and 73? Okay. So I'm going to go ahead and open that up really quickly just so we can see it. Precalc. If you guys got that far in homework, go ahead and just stick around in your homework spiral and you can work through it with me. If you didn't get that far, maybe you want to open up your notes and then you can write down what we do in your notes and then you can transfer it. Or you can just listen, pay attention, and then watch the video tonight to be able to finish that homework. Does that sound good? Okay, so here we go. Whether you're in your spiral or whether you're in your notes, let's go ahead and go to section 1.9. 69 and 70. Oh, 69 was a whole different function. Sorry, a whole different direction. Let's go to 73. He's the one that I thought was kind of funny. All right, let me see. Do I have him? Nope, I don't. I'm going to steal him because there's a lot of stuff going on that page, and for me to try to fit in work would be really confusing. So let's go steal him from right here. All right. If your parents have restricted your privileges, what have they done to you? If they have restricted your privileges, what's going on? They grounded you, right? They're keeping you from doing something. If they've restricted your privileges, they've taken away something. So, restricted privileges, you're not able to do everything that you want to, etc. If I want to restrict the domain, I'm cutting down my function. But I'm cutting it down in a very particular way. And this actually tries to explain it to you in the direction. In the direction it says, restrict the domain, cut it down so that the function is, I want to make it 1-to-1, and I want to make it have an inverse function. Not 2, just 1. Then find the inverse function, state the domains and ranges of each. All right, here we go. Kiddos, in your notes, didn't we actually already do this guy? Where am I? He was this guy, same one. We actually already looked at his graph. We talked about whether or not he was 1-to-1, and we found his inverse functions, plural. The directions say, no, don't find inverse functions, plural, find 1. Just 1 inverse function. So let me go ahead and draw the graph. If you're reviewing transformations, he's an x squared, he's a parabola that's been shifted to the right. And we already talked about how he's not 1-to-1 as he is. The whole thing is not 1-to-1, but if I cut him down, I have to include the vertex. I have to keep him. What if I only keep this side and I ignore this side? Because I'm allowed to restrict. I'm allowed to only look at part of it. So what if I just look at this part? Is that part 1-to-1? And would that part just have 1 inverse function? The answer is yes. The plus or minus square root thing that happened up here is because there were 2 different branches that were hitting through all the y's. This branch had an inverse function, and this branch had an inverse function. This problem is saying, no, we only want to talk about one of those branches. It actually lets you choose, but I would say probably the best way to choose is to choose the more positive side than the negative side. There can actually be a life lesson to that, but we'll keep going. Let's choose the more positive, not the negative. Or not the going to the negative. What x value is this right here? 2. So if I was to talk about the domain of this piece that we're choosing to ignore what would make it fail. So life lesson on that too. Keep coming. What can I say my interval is? Yeah, I could say x greater than or equal to 2, or x starting at 2 and going to infinity. That's my restricted domain. I'm just going to choose that. You could have chosen x less than or equal to 2, technically. You could have chosen negative infinity to 2, technically. But if I choose this one, x greater than or equal to 2. First of all, it goes as low as I need and as high as I need for this function. It has all of the y values in the range, but it also doesn't include any more x's that would make it fail. So I'm restricting the domain just to be x greater than or equal to 2, or x within 2 to infinity. How do I find the inverse function?
Switching the y.
Switching the x's and y's like we actually already did in our notes. And what we ended up finding was 2 plus or minus the square root of x. But since I chose the positive side, the side that's going to the positives, I'm just going to choose the plus, not the minus. And since there's only one, I get to actually name it the inverse function of f. This is the one inverse of this branch or this piece or this restricted domain portion of my original function. And so if I choose that, ironically, this is the hard part. And I haven't done this work, guys, because once again, we did it in our notes. We switched the x and y and we solved for y right up here in this step. So I just used what we had already done. Not the plus or minus, just the plus. What's missing is domains and ranges. So this is what I wanted to end with right here in homework. We do have the graph, and that helps. If I'm trying to think about the domain of f and the range of f. Don't we already know the domain because we made it? Okay, so the domain we're just going to use 2 to infinity. What's the range? How low does this guy go? 0. And how high does it go? So we're going to use y's. Now we have to kind of go back to the notes. In the notes I said, you have to switch x and y and solve for y for inverses. All the ordered pairs, the x's and y's switched. So what happens to the domains and ranges? They switch too. So what did describe the y's in the inverse, in the original, will describe the x's. I have no more work to do. All I have to do is steal stuff in a completely legal way. The x's of the inverse will be or will show the same characteristics as the y's in the original, and the y's in the inverse will be the exact same as the x's in the original. Kind of decapitated the f inverse, but that's okay. And that's the final solution. So restrict means to cut down. So only zoom in on the part that doesn't start failing the horizontal line test. So ignore one whole half that makes it fail. Write that restricted domain. Switch the x and y, solve for y, but only keep the plus, not the minus, as long as you choose the positive side, the one on the right. Then look at your graph. How low, how high, how left, how right, and then switch it. Okay. So that describes number 73. I think I only gave you one of those. Is that about right? Did anybody who went through homework, were there any more of the weird restricted domain? Okay. Huh? Okay. So then that wasn't too bad. 69 was a lot like our workspace, how we needed to switch the x and y and solve. So if you guys had any other questions on that, I will be here today after school. I will be here today during lunch to ask me corrections or homework 1.9 questions. So I'm going to go ahead and skip this example that was a lot like the homework problem that we ended up doing instead. Okay? We are going to go into section 1.10. Let's go ahead and transition into our notes. I'm going to actually cut down the notes just a little bit because you guys have seen all of that before. And actually, to be honest, even though this looks really, really messy, this whole page is reviewed. The book is using some snazzier terminology. So I'm going to highlight just a few things as you guys are writing. Line of best fit is the same thing as a regression. And everything else, to be honest, they might bring it up in like the terms for, I don't know, you guys know your vocab at the beginning of the homework from time to time. This might come up in the vocab, or it might be a part of one of the first homework questions. I'm going to actually put those in parentheses. That would not be something you need to memorize. But if they do talk about the line of best fit, we are going to use the regression feature. all of this stuff, wasn't this in the graphing calculator handbook? So I shouldn't really need to take a lot of time to review because I know you have the handbook, and in the handbook it walks through, or walks you through, how to. I know you're writing. I'm just going to distract you for 1 second. The handbook's going to remind you, ready? Pause. How to take a table and put it in your lists. How to take those tables in the list and go ahead and get a scatter plot and find a linear regression, the line of best fit, and to graph it. And here's the long story short, without using all the crazy, this would be good for an EP stats or if you're in stats in general, like a college course or a high school course. This would all be good, but for our purposes, to figure out whether or not it fits well, we're just going to look at the scatter plot and say, hey, how close is the scatter plot to the line? Super close. How good is the fit? It's really good. That's enough. What if these points were like all over the place? It wouldn't be a good fit. But as long as they're pretty localized around the regression, we'll say it's a pretty good fit. And we're not going to go into any more detail than that. So let's go back to this page. I want you to make sure you get down the line of best fit. You're going to use the regression feature. I want you to get down, review the handbook where we talked about how to do the lists and how to run the regressions and graph the scatter plots. But everything else is extra above and beyond what we're going to do in Precalc. Okay? And this is where section 1.10 starts. It's just reviewing word problems with tables and with regressions. Yeah, sure.
What is our homework due for this?
Give me a second. Now you guys write down the very beginning, and then I have to talk about logistics. But the reason you have the question is the whole reason I have to go over it. It's a good question. Homework starts here, but it ends with very different word problems. Very typical word problems in math or just in general, like in different fields of study. There are tables of data and putting it all together and seeing what the trend is and trying to figure out an equation to predict what's going to happen later. This is a big part of modeling with math. The dilemma is we have basically another category of word problems that involves words like direct variation, inverse variation, joint variation, combined variation, different terms and vocab that we talk about, and talk about what that means for equations, and then practice having an equation, plugging in clues, solving for variables, getting a nice final model at the end, a nice final equation for our data. The struggle is that we're going to do that in 2 minutes. No. So, basically, we got behind in section 1.9 just a little bit. Because we got behind in section 1.8 just a little bit, only because we got behind in section 1.7 just a little bit. So, the struggle is, tomorrow is supposed to be dedicated just for a test review on chapter 1. We need to take tomorrow to basically finish up 1.10. So, 1.10 homework is not going to be due tomorrow, it's going to be due Friday, which means, can we have a test on Friday if we just finished all of our material? We could, but we should. I really was trying to get the test in before the weekend so we have no homework this weekend. But instead, I think it's better for all of you guys in both periods to have the weekend to finish reviewing. The test will be on Monday, but you have the weekend to catch up in your homework spirals if you've gotten a little behind. And you have the weekend to study your notes, because some of you need to do that. You didn't do that in the first test, and you actually study, memorize some of the formulas, memorize some of the terms like symmetry, even odd, transformation. You're going to have the weekend to study. Now, what's the dilemma whenever you have a test after a weekend? If you're not wise with your weekend, what could end up happening? Yeah, it could be bad because you just forgot everything. But could it also be good because you take the extra time and trying to get it? Okay. So we're going to have a full review on Friday. Hopefully the whole day Friday can be reviewed. I'm hoping tomorrow we spend half a day on the notes, half a day on homework. That's my hope. Without going over any homework questions on 1-9, just get to focus on 1-9. And if we're able to finish up 1-10 pretty well, there is a chapter review with different problems. Some of you, if you have tutors, you can try to meet with them this weekend, go over the review. You can plan to stay in Friday. I'm not planning on meeting early or anything like that. So you can plan to work on the review with me during lunch after school on Friday too. Please, 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 with the extra time, what do you need to do? Catch up and study. Does that make sense? Okay. If any of you guys have fallen behind, I can help in any way, shape, or form during lunch or after school today. I'll try to help as much as I can, and if you need more help, I figure out more help than I can do. I'll see if there's another student that I think would be able to sit down and tutor you for a while as well, whether today or tomorrow or Friday. The one dilemma is today during period 7, I will not be here. I have to go do some observations as the department chair of class. But I will be period 7 tomorrow and probably the rest of the week. Sound good? Questions? Logistically, we're okay on what's going on? I would say you should probably do the regression-y stuff at the beginning of homework, and then maybe start going through your notes and figuring out what you need to be studying. You could, if you want to, like skip a couple pages in your spiral, start on the test review, but that's only if you want to go above and beyond. Most people on Wednesdays are pretty busy. I don't, but say I need to go do observations. Today I won't be here 7, but usually I am. Usually I am.
Friday next week. You got the B, right? You got grade.
I have 97.
The corrections are turned in, so it's full credit. I just need the test to be able to give you points. Does that make sense? So see if you can find it. Maybe look in Mocker. Okay, so Lowell, what I'm gonna have you do starting tomorrow, I can't explain very fast, I swear. I'm sending this to you. That sound good? Okay. What I've shared with you is some different stuff from Calculus BC. And you know how in Calc AP you like pull records with all the things ready for you guys? I need to make that for BC, it's a new book. So what I've done, I'm gonna have you, do you have a login for school computers? On the computer. I'm gonna log out. You're welcome. I'm gonna log out and have you log in. And then you can go to your computer. And when you do, you're gonna open up chapter 2 right here. And you're gonna open up chapter 2 homework sheets. So you can see what problems. And you're gonna open up chapter, it's weird, but it's the 2. Okay. And what you're gonna do, so then if I look here, you don't have to do 1, 2, and 3, and 4, just 2 and 4, just the even, because odds are in the back of the book. If you go here and type in snipping, yeah, then you can say, okay, 2 and 4 and 10, and you come here, and obviously get your snippet, and go find 2, and then that automatically copies, all you do is, yeah, just keep going. But what I would probably do, I'll start it, sorry, I didn't have it started. If you can do this then. Then I can, then you can see it. There we go. And then just copy and paste all the way down. Okay. Does that make sense?
Who would it do tomorrow?
No, you can do it in class, and it can take multiple days, it's just a project. Is that okay? Thanks, Laura.
Thank you.
You're welcome. Hi, kiddo, what's up?
Can you do Max and Nuggets?
On Friday?
I don't want to.
Oh, I don't know. Sorry, that's what Maggie said. When do you want it?
Is Monday good? Because I know a lot of clubs are open.
Oh, that's true. It's a lot of clubs meet on like Wednesday, Thursday,
Yeah,
Friday.
and then Monday's a good day for naps.
That's true, because you're dead after the
Yeah.
And there's not usually tests on Mondays.
And then like if warm up the nuggets in the microwave at the same time.
Oh, look at you. That's so cute. You have problems with boys. Okay, that's good. Boys and other things, but yeah, definitely boys and other things. No evil. You are hilarious.
Thank you.
If you guys want dipping sauce, you can keep it in my fridge.
Okay, gracias.
They're done. What's up, then?
Hello, 6.
I forgot to pause my video. We're recording right now. Let's not record.